What to know about geography today? The summit of Mount Everest is made of marine limestone. The highest point on Earth was once at the bottom of the sea. This claim is scientifically accurate, but it needs proper historical and geological explanation. Around 200 to 250 million years ago, the land that is now India was part of a southern supercontinent called Gondwana. Between India and Asia lay a vast ocean known as the Tethys Ocean. This ocean contained marine organisms, coral reefs, and shell-producing animals. When these organisms died, their shells, rich in calcium carbonate, accumulated on the ocean floor. Over millions of years, pressure transformed these deposits into marine limestone. India began moving northward due to plate tectonics. Eventually, the Indian plate collided with the Eurasian plate. This massive collision crushed and folded ocean floor sediments, pushing them upward and forming the Himalayan mountain range. This process is called orogeny, or mountain building. The collision created the Himalayas, including Mount Everest, the highest point on Earth at 8,848.86 meters above sea level. The top layers of Everest contain marine limestone, fossils of sea creatures, and sedimentary rock originally formed underwater. This proves that the rock at the summit was once seabed material. British expeditions noticed fossil-bearing limestone near Everest summit in 1924. In 1953, when Edmund Hillary and Tenzing Norgay reached the summit, geological samples further confirmed sedimentary rock presence. Later geological surveys identified crinoid fossils, which are marine animals, and limestone formations typical of shallow seas. Marine organisms lived in the Tethys Ocean. Their shells accumulated on the seabed. Sediment compressed into limestone. Continental plates collided. Seabed rock was uplifted thousands of meters. Over millions of years, erosion shaped Everest. Today, that former seabed is the highest point on Earth. This demonstrates the power of plate tectonics, that Earth's surface is constantly changing and that mountains can rise from oceans. It also shows that geological time operates on millions of years. The Himalayas are still rising today, about 5 millimeters per year. Yes, the image statement is scientifically correct. However, it simplifies the process. It wasn't suddenly at the bottom of the sea. It took hundreds of millions of years of geological transformation. The formation of Everest is one of the strongest pieces of evidence supporting plate tectonic theory. This theory was confirmed in the mid-20th century, and continental drift, first proposed by Alfred Wegener in 1912. Primary evidence: rock samples and fossils. Secondary evidence: geological surveys and tectonic studies. Chronology: 250 million years ago, an ocean existed, followed by collision, uplift, and the present-day mountain. Verification: modern GPS and geological mapping. The highest point on Earth was indeed once part of an ancient ocean floor, making this image scientifically grounded in geological history. If you enjoy the video, please like, comment, share, and subscribe to this channel. Thank you.